All right, let's go ahead and get started. Welcome, everyone. Thanks so much for coming over here for this code talk. My name is James Hood. I'm a principal software engineer at Amazon. I know it's kind of late in the day on day one. We're going to make sure to keep it interesting for you. You'll definitely want to stay for my part. I have a very ambitious code exercise that I'm going to do for you all, so we'll see how it goes. But first, I want to hand off to Maish.
Thank you very much, James. Firstly, thank you all for choosing us over the expo hall. There's more swag tomorrow, don't worry. There's more than enough for everybody else. My name is Maish Casing, and I'm a senior developer advocate with AWS. I work in the marketing organization. And before we start, there's a couple of things I'd like to get off or clear. Firstly, I have two hearing aids. So if you have a question, put up your hand. I can see, not very well, but we can see. Put up your question and please speak loudly so I can hear properly because we don't have a mic running around the room. That's number one. Number two, we're working with code assistants, which means the code is whatever. When you work with a code assistant, it's non-deterministic, and James will give you the actual good way we use that word perfectly, how we try to use it, at least internally. And number three, because I'm going to be typing, and James is going to be typing, a part of this talk is going to be done sitting down over here in front of the laptop, because it's pretty difficult to do that while we're standing up. So, how did this come about? Which is actually quite interesting, because I was watching a recording of a video that James did for an internal, what we call principal engineers that give, on a regular basis, that give talks internally in Amazon. And I was looking at one of the videos, and I said, this is something that we have to talk about at reInvent. And I said, James, you want to come and do a session? I said, yeah, why not? So the reason we did this is because I think the story that we have to tell is, in Amazon itself, or in AWS specifically, we have kind of adopted generative AI tooling with open arms. We use it all day, every day, anywhere and everywhere. And we're here to share a bit about how our story goes, how we do this internally inside Amazon. We're not going to be giving any trade secrets. A lot of it is common sense, but it's good to see it like written out in a proper way so you can understand how that works. And what we did internally in Amazon, we use something called a mechanism. Has anybody heard of an AWS or an Amazon mechanism? Mechanism is a tool which we do where when something works, we like to share that with the rest of the company. And we take it and we codify it or put it into a tool and we call it a mechanism. And this mechanism works very, very well with one of our leadership principles, which is invent and simplify, where we take a virtuous cycle and it reinforces the behavior for other teams that can use it. So instead of everybody having to reinvent the wheel, one team does it, gives it to everybody else, and everybody starts contributing directly back into the tool to make everything better. So, should we start jumping in? First things first. Can we move over? Yep. Thank you very much. The code that is being used here today is on a GitHub repo. If you want to take a screenshot of that and follow along, you're more than welcome, some of it. For example, the examples that I'm going to give are available here as an open source repo that you can use and catch them later, and also some of the work that James is going to do afterwards of how we use this also in Strands. So let's first go to how we use this internally. And forgive me, I'm going to go and sit down. So when we are talking to an LLM, we have something what we call zero-shot, one-shot, and a few-shot prompts. When you talk to an LLM, there's a number of ways you can do that in different means and different interactions. The first one is what we call a simple shot. In other words, you ask the LLM a question. And this, of course, I'm working over here in the Kiro CLI. It can be done in any coding assistant, but we're going to be doing everything over here in Kiro. So asking a coding assistant question will give you an answer. And not necessarily always the answer you want. So in this case, for me, it is creating code and it does it all in Python, which is based on whatever the LLM has been trained. And slowly but surely will give me the code that I want and will give me what I asked in this case was a script which will validate an IAM policy. And this is working very, very slowly, but we'll have to deal with it. Okay? So it gives me the code that I want to create, and that is one way of interacting with an LLM. But we have found that there's better ways to do this. Here it gives me the function, exactly what I asked it to do, what the function does, and what it will return. But that is a zero shot. In other words, you just ask an LLM to do something for you. But if you provide more context to the LLM, for example, I know how to write a function which does, in this case, a validation of an email. This is what I know. And I ask it to continue to do the same question. In this case, things are going to change. Because firstly, it understands I didn't want the code that I wanted to be generated would not be in Python because I gave it an example, in this case, in JavaScript. And it gave me the answer. So we said the first is zero shot, you just ask a question. The second one is a one shot, you give it an example. And when we have a few shot prompting, you can give it multiple examples, which gives even more context. In this case, this is what I know, create the same function. And we'll see that the LLM, when it answers you a question, because you've provided more information to it, it will give you a slightly different answer. In this case, there is a very, very slight difference. In other words, it did remove the example policy usage, or the usage for the example which it wanted to explain to me, because it understood that I know what I'm doing, so I don't have to generate extra code. When do we use this? This is what our best practice for this kind of work is when you have a very simple task, use zero shot, just ask a question. But when you have more complex task, and that needs to follow more of a specific pattern like we'll see further on, use few shot prompting in order to provide more context to give you something which is more relevant to you. Another way we use this as well is something which we call providing more information to the LLM is what we call, when you start prompting to an LLM, you use the system prompt, a contextual prompt, or a role prompting. And how does that actually look? So let's have a look at that here. A system prompt, again, is a question. In this case, I asked the LLM to create an EC2 script for me with a specific tag and give it to me as a bash function. So the LLM will go and start thinking, create pretty much what I asked for it to do, a bash function with everything inside. And this is fine. This will work. You can run this bash function or this bash script, and it will start querying all your EC2 instances with the specific tag. But I can provide also, in this case, some context. And in this case, I'm giving the LLM, as part of the same question, more context of how I would like it to think. In this case, I'm saying our team manages multiple instances across multiple accounts, and the way we organize our project. So I would like you to create a script that will also be suitable for this. I could have given that same prompt, but when we use the actual context prompt, we start giving the LLM more information about how we would like to work, and it will create the bash script for me with the examples and whatever else it is. And so this will currently go through and print them out screen by screen. The last one we have is a role prompting. Role prompting is okay. It's pretty much the same as what we call a context prompt. But in this case, we say, okay, you are a. A lot of people use this, and when you start prompting anything, you are a specialist in nuclear technology. Please create something for me, or you are a radiologist that knows how to diagnose different MRI things. So you give the LLM, which you're working with, different context. And in this case, I'm asking it, you are an AWS senior solutions architect or solutions architect, and you manage infrastructure, and start creating a script for me. So in this case, probably the script will be very, very similar to the first one, but there might be extra nuances because it has already some kind of idea of what kind of information you're looking for, and perhaps how to cater that information directly for the person for you. Any questions so far? No question? No question? No? Perfect. Okay. The best practice that we have for this is, of course, to combine these techniques when you're talking about complex tasks. Start with the context, then define the role, and then specify the task and the desired output format. In other words, be as specific as you can when interacting with some kind of coding assistant so that you can get the most benefit out from these tools as well. The next thing I would like to show you is something which we call self-consistency prompting. This is a powerful technique that improves Kiro's CLI, or in this case, in our case, some kind of reasoning by generating multiple different independent scenarios or solutions to the same question and same problem, and asking it to select that same behavior. Let's have a look at an example. Self-consistency. I ask Kiro a question. I need to design a complex architecture for multi-region, highly available applications. I would like it to explore 3 different approaches to this problem, and these are the factors it has to take into account. In this case, cost, operational complexity, latency, and after it's considered these 3 different options, to select one of those and give me a recommendation. So, assuming this works, and we'll see if it doesn't or not because I had some problems before, it will start going through the scenario. Okay, you want to build something, the 3 different ways of doing it: active-active, active-passive, and active with read replicas. And it's asking me to give more details. I could, of course, say I want this as a front-end application, whatever else it is. In this case, I'm just going to say there are no more details. It will start building whatever an application it decides. But now it will start going through these. There's 3 different multi-region deployments, 3 ways of doing it: active-active, active with a global database, active-active with a primary writes with balanced, and it will give me, these are your recommendations. The way we use this enable us, this way that works is because the technique encourages the LLM, in this case Kiro, to generate diverse reasoning paths for the same problem. By exploring multiple perspectives, Kiro, in this case, can identify more robust solutions. And the final answer that we get from it, because I asked it to choose one of the 3 out of whatever it is, will probably be more consistent based on if I do this more than multiple times. When do we use this self-consistency model? When we have complex architecture decisions or problems we're trying to solve, troubleshooting with difficult root causes, some kind of security analysis, and of course where we have like performance optimizations, we'll see that example in a second, that need to be considered when we need to think very, very specifically what the options are and how we have to address the problem. And the best practice here is, of course, always ask the LLM to generate more than one answer, so it can give you more options, firstly, because you don't have to always trust. You will start thinking for itself and provide you multiple solutions and ask it to choose out of the 3. Giving things more options, more than one option, will be very, very beneficial for you. Another way we use this as part of self-consistency is what we call a tree of thought, also for solving problems. So a tree of thought is essentially asking the LLM to solve a problem for me by giving it explicit directions how I want it to solve. In this case, I wanted to consider 3 possible bottlenecks for my problem, which are cold starts, memory constraints, and external API calls. For each of those bottlenecks, give me 3 different possible solutions, and for each of those solutions, evaluate the pros and cons. So I'm going from, I have a Lambda problem, these could be my different issues which I'm trying to, what I think could be the problem. For each of them, start looking at different options, how I would solve them, and in the end, bring this all together to give me some kind of a recommendation. So when doing this, of course, it allows Kiro to start working and trying to actually solve a very, very big problem. You define a structured exploration with multiple branches. Each of the branch represents a different aspect or approach to the problem. And Kiro explores each of these branches, and eventually it comes out with some kind of recommendation to identify an optimal solution. When do we use this? Again, with complex problems with multiple variables and, of course, decision-making with numerous interactions and factors which we have to take into account. And the best practice here for tree of thought is, of course, you have to structure your prompt with very clear branches and evaluation criteria. You just say, OK, just do a tree of thought and figure it out for me. It won't really help. You have to give it very direct instructions, how you want this to work, and it will give you a much more comprehensive analysis. And you can actually combine the 2. So you can combine tree of thought and self-consistency. In this case, it's even more complex. I want to design a disaster recovery solution, a tree of thought to explore, 3 different ways. For each of those, start analyzing. So in other words, we're combining even more of a complex way, but we're letting all what we love to call the undifferentiated heavy lifting is over to the LLM, and it provides me with an option or a solution. So here it goes through the different options, as you can see. And the way we use this, of course, is designing multiple, when we use for mission-critical system design, or we have architectural decisions that we have to take, and we know that they have high risks on one way or the other, so at least we can get the information. And from here, it starts giving me an implementation and gives me the different kind of approach. Before the last time I did this, it actually gave me a matrix, but now I see it doesn't. So that's the wonderful thing about LLMs, it's not consistent. But still, when combining these techniques, be very explicit again how you want Kiro to follow this kind of trail of thought, providing clear guidance and how you want to organize the explorations, and all of this will give you a full, clear picture of what you would like to get. Expanding these tools with context. So I've been talking about context a lot over here. The more information you provide, the better answers you will get. And of course, with Kiro, for example, almost any other tool, you can add context. So in my case, in Amazon, we have a kind of peculiar way of writing stuff. Okay, we have a writing style internally, and in my case, of course, and it'll be the same thing. Usually these things have been documented up the wazoo and everything is working correctly and you have a knowledge base of how that works. So if you add that into your LLM, you can use that as part of the way you can use it to help you. So in this case, I've added the way we write narratives, 1-pagers, 6-pagers, PR FAQs into the context. And I'm going to ask Kiro to write me a narrative. And of course, this is not a real product, so please don't shoot the messenger, whatever it is. But I would like to start how it helps tadpoles to grow into frogs. But because I've already loaded all the context and the way we write documents, it knows exactly how to structure it. It knows exactly what questions to ask me in order to help me fill in the way to make a more clear and concise and comprehensive document, which I need in order to help me. So in this case, there's success metrics I need to add in, and there is recommendations and the market opportunity, everything we know how we usually write a document. But using these kind of tools in L to help you do these kind of, to write these documents makes things a lot easier. The last thing I would like to share just before I hand it over to James is one more technique which we use, which we call explore, plan, code, and commit. So, one thing which LLMs are very, very good is they're understanding what you've written. So you can provide it the code. And in this case, tell it to, I've got a code base over here, in this case, 3 different JavaScript files, where I've written code and this is what my code base. And you can do this on large code bases if you would like, and it will start reading all the documents and understand all the different dependencies. And I remember James showed me an example of how you can do this to create all the documentation and the diagrams and the flows and the APIs, and you might even show that later on. So in this case, I've got 3 different files over here, which does a authentication mechanism for some application. So the LLM now understands what I have in my code base. I can ask, as we said, the first one was to explore. Then I would like it to plan based on what you've already understood from my code base. Please implement a password reset feature. So again, the style is already there. The way I write my code in the same kind of style as well is also over there. So I can go in to see, and I gave you some more instructions to take in security considerations, that has to be robust, et cetera, and it gives me a plan of how I'm going to implement this feature. And then, of course, we explore, plan. I'm going to ask it to now create the code for me, because it already has, and of course, I can iterate on this plan and make it more robust to add in more information according to what I would like. But based on what it already knows in this specific example, I'm going to ask it to write the code for me and make the changes. So this is a way which we use this mechanism of what we say, explore, plan, code, which is generating the code in this case. And it will be over here to create a function. And of course, commit we can also use in this case. I can ask it to commit the code for me if I would like. But in this case, I'm not connected to a production system. So I'm just going to ask it to use my internal style that I have, the way we write code, commit messages with the best practices, links to whatever documentation to it is. And I could also say also commit it and submit the PR if I would like to, but it's not connected to a repository. But here, in this case, there's no changes. But in other words, this would be the implementation. This would be how you would do it, and et cetera, et cetera. These are some of the techniques which we actually use internally every day, all the day. And the good thing is we've codified a lot of it as well. And in the repository, which we have shared in the beginning of the session, and if you want at the end of the session, we didn't take this QR code, we'll put it up again. Or actually, I know what, I'll actually put it up now, it's easier. Whoever hasn't taken a picture of the QR code can use it now. The actual code that I just, with all explaining all of these examples today, is up there as part of the open source that you can actually use it and see how you can, of course, implement it internally in your organization or expand on it and add whatever kind of best practices you have that you have learned from your things. And with that, I'm going to hand it over to James to talk to us a little about strands, agents, SOPs.
All right, thank you. Do you mind grabbing this? All right. For those of you who came in late, my name's James Hood. I'm a principal engineer at Amazon. I've been with the company 16 years, most of that time in AWS. I spent about 5 years in retail fulfillment software in the middle there. And I am also a former AI skeptic. My previous experience with AI before this year was trying out a bunch of flashy demos on real world code and watching it crash and burn and feeling very skeptical and not very satisfied. That changed for me this year, early in February, where I realized that some of these techniques that Maish was talking about, it's really the combination of the tools. Reasoning models got better, MCP became much more popular, and then, but my big aha moment was around the techniques that we use. So today, I have a very ambitious code talk for you. I'm going to talk to you about Agent SOP, which stands for Agent Standard Operating Procedures. And this is something we just open sourced less than 2 weeks ago. It's something that was actually an innovation internally by our builder community. And I'm going to show you why they're so cool. They're a deceptively simple concept that is incredibly powerful when you use them. Maish was just showing you a lot of great prompt engineering techniques, and to use these LLMs and be successful with them, prompt engineering is an important skill to have. However, did you notice he was copying and pasting a lot of prompts, right? Earlier this year, that was happening around Amazon, people copying and pasting these kind of magic incantations, and we decided there had to be something better, and that's what agent SOPs, that's where they came from. So SOP stands for Standard Operating Procedure. A standard operating procedure is a document that gives a detailed step-by-step list of how to accomplish some routine task. So I'm going to start out with, I actually have the agent SOP, let me see if this is the right window, nope. All right, so I'm in the agent SOP directory right now, and I have as part of this open source offering, we released the Strands Agents SOP MCP server, and this MCP server includes some prompts by default, and one of these prompts is called code-based summary, and I'm going to go ahead and run it. What this does, this is an MCP prompt, and agent SOPs you can think of as kind of a super prompt for an agent. I'll get this one started, and then I'll break it down for you. So this one is going to help me summarize my code base. Code base path is a required parameter, and it said it'll default to my current directory, which is what I want. I also want to consolidate it, or I want to generate a consolidated file, and the default is agents.md. So I'm just going to say consolidated true. OK, and then it's going to get going. All right, so now let's take a closer look at this code base summary. This is the agent SOP repository. And if I pull up the actual code base summary SOP, what you'll see is it's actually just Markdown. And it has a title. It has an overview of what the SOP does. It says it analyzes a code base, generates comprehensive documentation. It does support this parameters section with some of them optional and some of them required, the optional ones having defaults. And then it's a list of steps. It just says step 1, set up and directory structure. So initialize the analysis environment and create necessary directory structure. But this is where the magic happens. So step 1 is set up in directory structure. Step 2 is analyze code base structure. Step 3 is generate documentation file. But what you'll notice is that on each of these steps, not only does it give a one-liner of what that step is, it has this list of constraints. And these constraints use this RFC 2119 style keywords like must, all in caps, or should, or must not, or may. And it constrains the behavior of this step. It adds these constraints saying you must validate that the code base path exists and is accessible. You must create the output directory if it doesn't exist. If we look further down, you can see here, you must use mermaid diagrams for all visual representations. So what we've found, so again, agent SOP, title, overview, parameters optionally, and then steps with constraints. Finally, examples, because LLMs work very well when you give them examples. And then troubleshooting steps as well. These are still examples. Yeah, and then troubleshooting steps. What we have found is that agents and models are extremely good at following these instructions. This took us from kind of models going off the rails all over the place. Like, I could just prompt it and say, explore this code base and write up some documentation for me, and I could run that 20 times and get very differing results. But with this SOP format, I've been talking and showing you this. In the meantime, it's been generating these files. So code base info, this gives an overview of the code base, gives a description, gives the technology stack, it gives the project structure, and it will do this every time. Every time you run it, this document will contain these sections. There will be some variance in what it describes, but it'll have your code base info, your architecture, which if you remember, I said to use mermaid diagrams, so it draws up these mermaid diagrams of kind of the architectural structure of this code base. You can see that. It does components. Oh, it just added interfaces, so it's running. And then it's going to generate all of these summary files. And then from that, because I said consolidate true, it's going to generate a consolidated agents.md file for my coding assistant that is made up of all of this information that it found. So now my agent is going to be ready to go. I'm a principal engineer. We have these principal tenets at Amazon, like have resounding impact. One of them is called technically fearless, and I can tell you that thanks to AI and these agent SOPs, my level of technical fearlessness has grown orders of magnitude this year because I can go into any code base and I can run this, and then my agent has it. I can read it, obviously. I can read what the code base is like. And then my agent is also geared up at that point to then help me navigate that code base and even implement features and changes in it. Maish showed you that context feature. Maish had showed you that context feature. I actually wrote that. I went from concept to PR in 2 days. It was in a code base that I wasn't on that team. It was a code base that I wasn't familiar with in a language that I didn't know. And it went from concept, I thought I was building a proof of concept. It went concept to PR in 2 days, and then concept to production in 7 days, which was wild. And that was kind of my mind-blowing aha moment from earlier this year. Okay, so you may be looking at this agent SOP, and first off, like we've made these 4 agent SOPs available to use. Because they're really from internal Amazon. Like, we actually use these internally. These are by far the most popular ones. Now, looking at this code base summary SOP, you may be thinking, boy, that looks like a pain to write. It's very long and arduous, and I don't recommend you write them by hand. I write them with my AI agent. So what we've done is we've created a steering file. And so we've created a steering file that defines this SOP format for the agent. You don't need to worry too much about this, but when you install the agent SOPs, so we have this strands agent SOPs CLI. that you can use it to run the MCP server. You can use it to convert SOPs over to agent skills from Anthropic, if you've heard of those. And then there's this rule command as well, where you can say rule, and then it outputs that rule. And there are instructions in the README on how to put that into a cursor rule if you like using cursor, or put it into a Kiro steering file, or the nice thing with agent SOP is that it's even tool agnostic. Any LLM, right, any AI agent that can take an SOP can work with this. So I want to show you really quickly authoring, what it looks like to author agent SOP. So I'm going to add, I already copied that rule into my Kiro steering files, and so now you can see that this just pins this format file into the conversation context. So even if I run clear at this point, so I've cleared my conversation history, the context command makes sure that this stays pinned. So I can say create an agent SOP that, given a person's name, outputs a short, fun poem incorporating their name. And then over here, I'm going to open up. So I've pre-configured, now that MCP server can take an additional parameter where you can specify different folders for it to look for SOPs in. And so I'm authoring this into one of these SOPs. So now I have this like name poem SOP. And so if I start up another session of Kiro CLI with that MCP server loaded, and then I check the prompts. All right, you'll see that now my name poem prompt is here. So I can run my name poem prompt, and it'll say, OK, I need the person's name. So I'll put my name. Oh, wow, it's confirming the spelling. You gotta love LLMs. That's awesome. All right, so here's my poem. OK, so create a poem. Now let's say, so we can take a look at what it generated, right? So it generated, it's following the same format. This title, overview, parameter, person's name is required, right? And then it just has these steps and then an example. But let's say I want to change it. Let's say I want to say update to include an optional hometown param. And yeah, I'll just say that. Let's see what happens. And then I'm going to have to reload this after. OK, so it adds the hometown. And then hopefully it'll know I mean to incorporate it. OK, should incorporate the hometown if provided. So it's making those updates because it knows the format. It's making those updates to the constraints. So you can just chat back and forth. You can try out your SOP, and then if you see it behaving in kind of an odd way or a way that you don't expect, you can go back to your authoring chat and say, hey, I want this to behave this different way. It's doing this right now, and it'll add constraints, which the model will then mostly respect. Yeah, these are still agents, and so I'm going to say name poem. Now, you can pass in user input. I don't know if you're kind of eagle-eyed, you saw that this parameter is actually called person name. When I pass in the parameters, I'm passing it to the LLM, so I don't have to be exact. I could put, so I'm from Tucson, Arizona originally. But I could have put, my name is James, and I'm from Tucson, Arizona. And that could have been my input, and it will figure it out. OK, so now I gave a little poem that talks about the desert and saguaros and stuff like that. OK? All right, so as a former AI skeptic, cute stuff like this is fun, but I like real-world stuff, right? That's what's most convincing to me. I just wanted to give you a simple example so you could understand the SOP format. But why don't we create another SOP that you might find slightly more useful for your job? How about create an agent SOP that triages GitHub issues for a given repo URL. Let's try that. Now, keep in mind, I have the GitHub MCP server loaded up in my agent's context. So as it's authoring that SOP, it knows what tools are available to it, and it can. So that's you need to have the MCP servers that are relevant to what you're trying to do in here. Anyone else want a poem about them while we're waiting? Any questions at this point?
I have one.
Sure. Hand right
first.
before yours, Mesh.
Not, I guess, exactly on top of it, but something that was mentioned earlier. When you're providing code to the LLM, what are your recommendations for making sure that sensitive information isn't included in the source?
Yeah, so the question was, when you're providing code to the LLM, how do you make sure that there isn't sensitive information in the code that you provide in your prompt?
Yeah,
or
like what would you consider information that you want to not have provided to the LLM? Like obvious, usernames, passwords, things like that, but anything else that you recommend?
Yeah. So the question was, is there anything that you would be careful about having provided to the LLM? I do have to say that internally we use Amazon Bedrock, which essentially provides you this like account level privacy and is not sending your requests to like third-party model providers. So I would say internally we worry a little bit less about that. About like sending that kind of information. I still just as an engineer, I don't have passwords or credentials in source code. Like that's just a general security don't. So I don't generally like that's not going to go to the large language model because of that.
So would you say it's heavily dependent on the LLM that you're using, right? Like,
Yeah. I'd say that I guess the main thing I would say is with Amazon Bedrock, it's much less of a worry because AWS is very concerned about that privacy and about just like all of our AWS services where you have to explicitly give permissions and IAM permissions for any of your resources or data to be touched. So similarly, Bedrock follows the same paradigm.
But I think that's important to point out. Bedrock guarantees that.
Yes.
With like a separate entity from the model provider, so they don't share your Bedrock data with the model. Like same as running local. If you're running local, assuming the model's not, running unsafe code and sends the results up to the owner, which they're not. But you've got a level of guarantee there.
That's right. All right, so I have my GitHub issue triage SOP here. It takes a repo URL, like I said, and then it retrieves open issues, analyzes each issue, recommends labels, and then generates a triage report that it's looking like it's going to write it to a file. That's not exactly what I want here. I'm going to say for triage, search for issues with no labels. Those are the ones to triage. I also want you to comment a triage comment in each issue and apply relevant labels. Don't write the report to a file, just output it. And also add a dry run flag that won't actually make the comments and just print them out. All right, that dry run's just for demo purposes. Okay, so you can see it's adding the dry run option, defaults to false. I'm gonna close this out. And sorry to rush along here. Like I said, I have a very ambitious, I'm gonna see how far I can get coding an actual feature in front of you all. All right, so it just updated my issue triage. I'm gonna start this up again, and I'm going to use it Poetry's fun and all, but how many of you would benefit from automated GitHub issue triaging? Yeah, maybe? No? Nobody triages tickets here? Wow. Okay, so we can see this prompt has appeared, GitHub issue triage, and I'm going to run it. It's going to ask me for my parameters, and I will say my repo URL is this, and dry run true. And now, again, since the GitHub MCP server is loaded, it's searching through issues. You can see that it's searching for no label specifically. It's listing the labels associated with my repo, and then it's found, admittedly, this is a relatively new repo, so there's not that many issues. But you can see that it gives me this summary where it says, okay, recommended labels, bug, documentation, and then for this issue, this is a feature request or enhancement. And then this one, documentation or a bug. All right. Okay, so this one stands out to me a bit, this issue number 22, because I read it earlier. I didn't open this is a real issue, where they're saying, these MCP prompts are really nice, but it'd be really cool if we could have a list SOPs tool and a use SOP tool, right? That then the model can automatically try to use it. So let's implement it. Let's see, am I in the right directory? Okay, so at this point, if you remember, we'd run that code base summary. And so if I look at my context here, I now have this agents.md that was generated by that code base summary. I'm going to go ahead and clear my context here, and I'm going to run this agent SOP called PDD, which stands for Prompt-Driven Development, which was an internal predecessor to Kiro's spec-driven development that we came up with. So it takes a rough idea, and then it takes you through requirements clarification and research and everything and then comes up with a design and implementation plan. So it says, what's your rough idea? I'm just putting a link directly to this issue. Okay. And then we're going to see, we've got 20 minutes. We're going to see how far we can get. All right. So it's going to do some bookkeeping first. It creates this directory structure of these folders that are under this planning folder. And one's called research, one's called design, one's called implementation. Then it creates this rough-idea.md file where it just wrote what it read from the GitHub issue into here. And then it creates this idea honing file, and then gives me this instruction to add this expression to my context. So basically, anything that gets written into that directory structure will auto-add to my context. So it says, okay, do you want to start out with requirements clarification, which is the default, or do you want to start with some preliminary research, or do you want to provide additional context? I'll just say requirements clarification. Okay, at this point, it turns into a requirements coding partner where it starts asking me questions one at a time, saying, it starts asking me clarifying questions. So it says, what specific functionality should each tool provide? For list SOPs, should it return just SOP names or descriptions or parameters? For a use SOP, should it return the full SOP content? So I'll say list SOPs, return name and description, and entire parameters content. So I'll just say that, and then use SOP. I'll say this is because I wrote this, so I know. So take a look at the MCP prompt implementation and use the same XML output format, but without the run this part. So I told it to take a look at the MCP prompt implementation, so hopefully it should. Let's see. No, maybe not. The agents.md probably has that information. Okay, so next question. Agent autonomy and invocation. How should agents decide when to use SOPs? Should the tool be available at all times? These are MCP tools. They'll be in context at all times. All right, external SOP support. So should the new tool support external SOPs, which is this flag that we support? Yes. Yeah. So this may not make for like I'm like the anti-flashy demo person, and so I love doing like real software development in front of here, and you may see some like thinking time being spent and stuff like that, but this is real software development. Like this is how it actually works, right? We do requirements clarification. It says tool parameter and return format should return structured format or plain text. List SOPs can return JSON output. Use SOP. Yeah. I'm on the auto model right now, and I think by default it tends to use the like Claude 200K versions, Claude Sonnet 200K tokens, but we do have the 1 million token on here as well, Cloud Opus. I just am not explicitly using it. Let's see. Use SOP should take the SOP name. And I think that's it. Good enough. This is one of those features that's kind of in the middle ground where I do want to clarify some requirements, but I'm not, like, it's kind of a smallish feature, so yeah. Occasionally I'll come in and just say like, hey, why don't you just ask and answer like all the questions you have first, and then I'll tell you what I think of it. I'll do that on occasion. Error handling, list SOPs should just return an empty list. Use SOP can return a helpful error message. All right, so it's saying, I think I've captured core requirements. Again, I'm not usually under like the 20-minute time deadline that I am here. So sometimes I'll say, oh, actually it does have another question. Let's see. Integration with existing, how should these new tools integrate with existing MCP prompt system? Yes, both prompts and tools should be available. Sometimes when it says, it'll kind of decide, like, I think we have enough requirements. And sometimes I'll say, well, give me a list of questions you might have asked. And then he'll give me maybe like 8 or 10 questions. And OK, so it said we've covered the essential requirements. OK, I think we're good. So now I'm going to say research fast MCP and how tools are implemented, or I'll just say research how tools are implemented in fast MCP, the library we're using, and write a doc to the research folder. Okay, so it's going to do a web search. Yeah, so I can have it do this research. There are things where, large language models are very good at pattern matching. I happen to know in this code base that we just have MCP prompts in here. We don't have any tools. If we had tools already, I probably wouldn't tell it to research this. Because it's really good at kind of like exploring the code base and then just copying what it sees. But I want to hopefully ensure some success here, and so I had to do some research on the web to understand, like read the documentation and understand how adding tools works. But we'll see if it works. So this PDD script will write findings to this research folder. So you can see this whole time, we have this kind of planning folder that was created. My rough idea ended up in there. The idea honing, this is the documentation of all these questions and answers, and then research. Well, there will be something in research soon, and design. Okay, so now research, it just wrote this research document on FastMCP. And again, part of that agent SOP, I've written that it needs to, it needs to include references and the links of where it found all of its information in here. So all of those details, like that's not something you would want to repeat over and over again and manually writing prompts. That's something that you can encode right into that SOP, and then it works. Let's see. So in the interest of time, I'm going to have it move on to design. In the real world, like real world scenarios, I would spend much more time reading the research information, especially when it comes to design. For this one, I'm going to do like a really quick skim, which is very common when you look at AI demos. It's like, yeah, this looks good, and then move on. I spend when I used a form of this was before we invented Agent SOP, but I used a form of this with manual prompting to implement that context feature way back in March. And if it were really as simple as just, I don't care what you wrote, I'm just gonna keep saying yes and move on, I wouldn't have gone concept to PR in 2 days, it would have been concept to PR in 2 hours, right? But and this is where I really distinguish what's going on here from vibe coding, which is a very popular term from back in February. For me, vibe coding is, I'm not even looking at the code, I'm just kind of letting the agent do its thing, and I'm kind of manually testing. And my experience with vibe coding is it's amazing for prototypes, amazing for little games I want to make for myself, not very good for production code. Because in production code, we want to make sure that there's high quality. We want to make sure that the design makes sense. And vibe coding, it's very easy to code yourself into a corner, like really, really quickly, and get to a point where you're telling it to fix something, and it fixes it and breaks something else, and then you like tell it to fix that, and you just code yourself into a corner. All right, so I have this detailed design at this point. And I'm going to have it keep going. But its next step is it's going to create an implementation plan. But you can see it creates this detailed requirements, and then it creates kind of this architecture overview of what it's going to do. And again, normally I would spend a lot of time reading this. This is a big part of teaching AI fluency internally in Amazon, is teaching these practices, especially to people who are newer to this technology or newer to software development in general. Like I said, when I built that context feature, yes, I didn't know the code base, and yes, I didn't know the language, but I've also been programming for over 20 years, which means that while I couldn't write the language easily, I could still read it. I could still read roughly what it was doing and what was going on. And so I was there with it as it was implementing this. Okay, so I'm going to just cancel it. It was just going to create a little project summary to wrap up. But this SOP, this is a very involved and interactive SOP, so you can see how powerful these can be. But it went ahead and created this like implementation checklist, which 10 steps is way overkill for this. So I think what I'm going to do instead is I'm actually just going to remove that. And I'm going to run this other agent SOP called code task generator. And this is another one that we use internally all the time. All right, so input is create code tasks for implementing the design in your context. And output directory, I guess I'll just say implementation folder since I had it. Okay, so what this one does, this one's really good for like kind of smaller tasks where you don't need this like really huge involved one. This one kind of prompts you first and says, okay, here's my proposed task breakdown. So I read everything that you have in context, and here's create this SOP registry and metadata extraction, implement list SOPs and use SOP tools, integrate tools with existing MCP server. Let's do it in one step. I'm giving a demo. So this one, there's kind of mixed, that's an area we're still exploring. In general, we're seeing things head toward that direction where you end up committing. There's kind of two levels of context, and you'll see it's really useful for agents to kind of like write a bunch of stuff down, and if you need to clear the context window, then it's still there. And kind of like when there are documents that are more durable over time, like design documents that stick around for a long time, those absolutely should go in the source code. But then there's more ephemeral kind of like notes as you implement, and you'll see when I get to this implementation, all right, this one created this code task, and the file it created looks like this, and code task generator SOP, it basically creates like if any of you have an issue tracker, it's like the issue you wish everybody wrote. It's like this very detailed issue with description, background, reference documentation, technical requirements, dependencies, implementation approach, acceptance criteria. It's like, if only, right? Well, guess what? With AI, we can do that. All right, so now that I have that, now I'm going to run this agent SOP called Code Assist, which is fantastic. Code Assist, again, these are like super prompts. Okay, so it said propose parameters. Oh wow, it actually already found my task description. Nice. I'm going to say, yeah, this all looks good. So Code Assist takes the task description, which can be a file path, or it can be, you can manually type what you want, and then a task name, and then a mode, so it can either be interactive or auto. I'm gonna go auto for this one, and then a documentation directory. Oh, actually, I'm gonna adjust documentation directory. Oops. All right, I'm gonna adjust it to be that, and then, and then the repo root in your current directory is the default. So the Code Assist SOP leads the agent through a much more opinionated way to implement code well. It uses test-driven development best practices, so it breaks it up into a red phase, a green phase, and a refactor phase. Red phase meaning it writes the tests first and then verifies that they fail. And then the green phase is it implements the functional logic until those tests pass. And then the refactor phase is where it runs the other tests, make sure it didn't break anything, and then refactors the code to kind of more concisely match the style of the existing code and do any cleanups. And then it commits it using conventional commit messages. So all of that rolled into an SOP. For anything other than like a trivial one-liner, this is the only way I code now. I use this agent SOP. It's fantastic. Yeah? Yeah, so the question is kind of, how do you differentiate between like greenfield versus brownfield, right? Like existing code base. This is an existing code base, although admittedly it's a fairly simple code base right now. It's not like, I spent my last 5 years working on AWS CloudFormation. That's a over 10-year-old code base. It's highly complex, highly asynchronous, right? Running code base summary on that, definitely more challenging. That's generally internally when we're doing any AI tools, that code base tends to be my stress test for any of them. So the code base summary does help with existing code bases, and I will say that there is a limit to like how well these AI systems can do, depending on how complex and how large the code base is. If there is a massive amount of cognitive load that you need to have in your head to make like a one-line change, not gonna help you as much. So an analogy that I like to give is like you can think of a commercial plumber who spends 3 days walking around a big industrial building and then tightens one bolt and is like, fixed your problem. And they say, that'll be $1,000. And they're like, $1,000, you tighten one bolt. And they say, well, okay, $1 for the bolt, $999 for knowing which bolt to tighten. So there is code that we have that's very much like that, where the actual change itself is not big, but all the knowledge and cognitive load that you need to make that change, that's where kind of the skill comes in. I've found that I tend to use AI for that walking around the building for 3 days part. I can cut that down, that time down, and then still make kind of the manual code change myself. Yeah, so when you start using Agent SOP, like, I know this is a code talk, and I'm doing coding. Hey, look, all my tests failed. That's good, right? We know we're good on that. So when we do these, so once you realize that these SOPs basically just automate an agent to do things with MCP tools that it has, you start realizing how many different applications there are. One of the reasons I was so excited to open source this is because there are literally thousands of these SOPs internally in Amazon, and we're using them all over the place because you saw how easy they are to author and use, and people are using them to automate operations. They're using them to automate coding, as you can see. Even productivity, if you have like Outlook MCP and Slack MCP, and if you have like the right MCPs in place, you can start. Like I have a productivity agent where I can give it a recording of a meeting and say, hey, transcribe this, add a meeting notes document to my Obsidian Vault that has the task breakdown for everybody, and then it creates like separate documents for each person and maps the tasks over, so I can click on that person and say, oh yeah, those are the tasks I'm tracking for that person, right? And AI helps me do all of that. So it's pretty wild. Yeah, the tasks I've shown are like a user story. Is that your question? Yeah. Yeah, the code task is like a user story. Oh yeah, so MCP is the way to connect your agent to various different systems. GitHub has their own MCP server, and you can also look at MCP servers elsewhere. Another thing we look at is Anthropic launched this thing called Skills, which with Skills you can, even if a tool doesn't have great MCP support, but they have a really good CLI, for example, you can write a skill that gives it all the CLI commands and tells it how to use it. And then that's another way that you can connect it. Yeah. Yeah, absolutely. All right, well, I was really hoping to get to a point where I could actually like show you that this works for real, but I think we're out of time. Maybe I'm saved by the bell, I guess. But anyway, you can see, so it's implementing this code. The tests are now passing. Yeah, it just passed with 97% coverage. It's going to update this progress document that it's been keeping, and then it's going to do a commit. Yeah. Cool. So that's all the time we have, but hopefully that gives you some insight into how we use agent SOPs. I really encourage you to check out the agent SOP GitHub, and if you wouldn't mind giving us a star, I'd really appreciate it as well. But thanks so much for your time today.